this video is again on dimensional analysis technique, but this time we are solving word problems. Here is problem number 1. Let's read carefully and please follow the steps I have for you on this yellow sticky note. All these steps I have on each page with every problem. A lab assistant needs to determine what quantity of sodium hydroxide he needs to order for a class. If each student will require 125 grams of sodium hydroxide and there are 30 students in a class, how many kilograms of sodium hydroxide should he order? So here we need to find out the equivalents, the basic relationships to get the conversion factors. So first thing here, it says each student will require 125 grams of sodium hydroxide. So this is your one equivalent. Per student, 125 grams of sodium hydroxide. From this relationship, we can find amount for 30 students. But wait, they want the kilograms here, not the grams. They want the kilograms. So we are going to need equivalent for the relationship between kilograms and grams, since here the given amount is in kilograms, is in grams. So grams to kilograms, this is another equivalent. I would start off with 30 students, okay, in one class, because that's my sample. Now for one student, how many grams of sodium hydroxide do I need? 125. So I don't want the unit student, but I do want the unit grams. So I'm going to use this conversion factor, 125 grams for one student. Cancel out student and student. Again, I'm not going to stop here since I have to find my answer in kilograms. So I'm going to convert this grams to kilograms, and this is the conversion factor I should use because this has kilograms at the top. My desirable unit is at the top and the unit I want to cancel out is at the bottom. So here you go, 1 kilogram has 1000 grams, so grams and grams gets cancelled out. Do the math correctly and don't forget the units. When you multiply everything at the top, then you multiply everything at the bottom, then the top, which is your numerator, the answer, needs to be divided by the bottom, which is your denominator. You are going to get 3.75 kilograms, and we have used two conversion factors here. Let's do another problem. Again guys, make sure to read carefully because you need to find the equivalents. A nurse plans to give flu injections of 50 microliter each from a bottle containing 2.0 microliters of vaccine. How many doses are there in a bottle? So what are we given here? It says for one dose we have 50 microliter. That is why one dose equals to 50 microliter in this sample. And the bottle, which is a sample of our vaccine, contains 2.0 milliliters of vaccine. Now they are asking us to find the number of doses, right, in a bottle. And for doses, the units we have is microliter here. So we are going to require another conversion factor between milliliters and microliters. Since here it is milliliters, but the answer we want is in microliters, the doses. 1 milliliters is equivalent to 1000 microliter. Now what is the relationship again between milliliters and microliters? Right here. We're going to pick the fractions which are appropriate depending how do we start and how do we end. So let's start with 2.0 milliliters over 1 times, I don't want milliliters anymore. What do I want? I want microliters. So let's see the relationship here. Since I want microliters, I'm going to pick this fraction, but 1 milliliters. Cancel out microliters and microliters. Now I'm going to look for the relationship between microliters and doses because I need the answer in doses. Here you go. This is a relationship. And what do I not need? I don't need microliters. So I'm going to pick this fraction because microliter here is in denominator and here it is in the numerator, so that we can cancel out that. One dose 50 microliter gets cancelled out, and you are going to do the math and you are going to get 40 doses. So what you did, you went from milliliters to microliters to doses, right? We again were using two conversion factors, 1 and 2. Let's do this one. A piece of block has a mass of 0.056 kilograms and a volume of 1300 microliter. We have to determine the density of the block in grams per milliliter. Now density is always mass per unit volume. Okay. Now here our mass is 0.056 kilograms and our volume is 1300 microliters. Now what do they want? They want the density in grams per milliliter, meaning we have to convert the given mass in grams to kilograms. No, given mass in kilograms to grams and the given volume in microliters to milliliters. Okay, this is what we have to do. Kilograms to grams and microliters to milliliters, because that is what is asked in the problem. Again, the two equivalents that we are going to use are here. Let's start with whatever is given. 0.056 kilogram is the mass and 1300 microliter is the volume. Now we want to convert kilogram. In the numerator we want to convert kilograms to grams. I'm going to use this one because this has grams in the numerator. Okay, and you again cancel out kilograms and kilograms. Now here in the denominator I have microliter for volume, but do I want the microliter or do I want the milliliter? I want the milliliter in my answer. So when you pick the fraction here, our microliter has to be at the top because I want to cancel microliter and microliter. Okay, microliter and microliter. So what am I left with? I'm left with grams and milliliters. This is what is exactly asked here, grams per milliliter. Okay, now you solve it. You're going to get 43.07 grams per milliliter. Now regarding the sig fix, guys, here whenever you follow the rules of sig fix for division or multiplication, you go by the least number of sig fix. Here you have 2. Again here also you have 2. So your answer should not have more than 2 sig fix. You're going to round off here and it becomes 43 grams per ml. Okay, keep reading the steps again. From here you always start from given, then times conversion factor, unit cancellation, math calculation and answer with the correct units. Now let's do the problem where I have 5 conversion factors. These are 5 equivalents coming from this problem. So read carefully again, guys. We should know how to make equivalents to get the appropriate unit factors. Now you want to know what you're given, what you need to find. Well, in this problem we are using again the 5 conversion factors and here are the 5 equivalents. These 2 equivalents, this one is given. Also the density, which is 1 kilograms per liter for water, is also given. So I wrote it from here. These we should know how to make. Right, so let's start here. A person drinks 8 glasses of water each day. So in one day a person drinks 8 glasses of water. This is one equivalent. And each glass contains 300 milliliters of water. So one glass has 300 milliliters of water. This is our another equivalent. How many liters of water will that person consume in a year? So did you notice? The given unit is milliliter. However, they're asking us to find the volume in liters. So we need another equivalent between milliliters and liters. So here you go. This is the statement for milliliters and liters. So this is our next one. And the last one is right here, which I made from here. And this is true only for water because liter of water is the one that weighs 1 kilograms, but not every liquid. So let's start with unit. A year, 1 year. So 1 year, again I'm going to do it over 1. We don't want here, here, and we know 1 year has 365 days, and this is what is given here. So I'm using this conversion factor. I want to cross out here, right? Now, in one day, 8 glasses of water. Do I want to keep days? No. So per day, 8 glasses. So here 8 glasses, this one, 8 glasses at the top. You cancel out days and days. Now the next unit you want, how are we going to connect these glasses? Here, 1 glass is 300 milliliters. Okay, do I need glasses? No, I don't need glasses, I need milliliters. I want to cancel that. So 1 glass has 300 milliliters of water. Cancel out glass and glass. Now again, can I stop here? No, I can't, because they're asking volume in liters. I need to use this equivalent also. Do I want the answer in milliliters or liters? I want answer in liters. Here, desirable unit at the top. So 1 liter, 1000 milliliters. Milliliters and milliliters gets cancelled out. Now when you do the math, multiply everything at the top, multiply everything at the bottom. So whatever answer you get in the numerator, divide that answer by the answer you get in the denominator, and you're going to get 876 liters. So this is the volume you have here, that this person is going to consume in a year. Now this is the second part. What is the mass of this volume? This volume of water in kilograms. So you have to convert this into kilograms. Well, I already have that from this density of water, that a liter of water weighs 1 kilograms, right? Just for water. So let's start with the given here over 1. This is my volume, and I don't want liters. What do I want in my answer? I want kilograms. So this is the one I'm going to use. 1 kilogram, 1 liter, liters and liters gets cancelled out, and you're still going to get 876 kilograms. Okay, now it's your turn to try out some problems. Please follow and double check all the steps. Attached are my quick notes as well here, and also more quick notes here for you. And the last thing I have for you is, I know you want that is the solutions to the problems that I asked you. Thank you, and I hope you found the video helpful.